All right, so my example of how I can use graphs to convey meaning to my students is this very open-ended example posted here. So this is something that I have given to students in the past where I say, tell me a story that goes with this graph. And we have a very vague picture here where we have three quadratic functions. We don't have any labels. We don't know what anything means. It gives the students a chance to really be creative. I typically let them work in pairs or small groups on this, where I want them to kind of go in whatever direction they want, hopefully taking some of the properties we've talked about within quadratic functions and incorporate them into some sort of storytelling idea. So here's the question. Tell us a story about that graph. All right, so in order to answer the question of us as students telling the story of what's happening on this graph, I first need to get some information from my graph. So first of all, I'm internalizing that all three of these graphs are quadratics that are all opening downward, which means that our A value, when we're writing this in standard form, has to be negative. That's something I remember from class. And a lot of the problems that we did that opened down had to deal with kicking something in the air, throwing something, launching something, something that would initially increase, hit a certain point, and then decrease because of gravity. So I'm thinking already of different ideas, and I'm immediately just thinking about football. With the Super Bowl just happening last weekend, I'm thinking maybe this could be different kicks or throws of a football. So right away I'm thinking, okay, well, if these scales are in units of 1 foot, 1 yard, yards might work, but I'm gonna go like 5 feet in each direction, and I'm just going to see if that works for now. Now, I know I didn't label the X and Y axis, but I'm just thinking if this is going to be a football, they can go a pretty long way. So I'm going to use 5 feet for now. Probably should have wrote that as well, 5 feet. So I want to talk about the green graph first, which seems to start down here, which if I'm going by fives, that would be at the ordered pair 10, 0. And I'm writing these ordered pairs down because I just learned how to work with different sets of data that resembles a quadratic and find the equation of that quadratic using quadratic regression. So I know if I can get 3 points off of this graph, I can get an equation for that using a graphing calculator. So now I'm going to take this point at the top here, which just as an estimate looks like maybe 27 and 83 or so. And then this last point down here looks in between, probably 42 and 0. Now I'm going to take those 3 points and plug them into my two lists and use quadratic regression to get my equation. Before I do that, I'm going to actually get the other points from the other graphs. The blue graph looks like it starts at 15, 0, then it goes up to about 44, and then it's about in between, maybe closer to 85, so I'll say 83, and then it ends at 70, so 72 and 0, and then my red one looks like the same starting point as the green one at 10, 0, definitely goes up the least, maybe 56 or so. So I'm going to say 47 and a half and 56. And then it ends furthest over here at 82, 0. Now I did go ahead and try and get some of these points ahead of time just to save a little time on the video. And again, we do have a little margin for error when we're taking these points off. But as long as I'm pretty close at each of those points, I should be able to get a really accurate quadratic model using regression to show that. Now, on the next screen, I'm going to show the quadratic model that represents each of these. So again, after using quadratic regression, I have our 3 quadratic models written in standard form. Just from these models, I can compare their y-intercepts, I can compare their a values. Now they are all negative, which is good because they all open down. I can compare the rate at which they are increasing or decreasing by their a value. But that doesn't tell a story. So now I got to go back to the idea of, okay, these are footballs. Let's say they're being thrown. And now I want to label more specifically what my x and y axis represent. This is where we can get a lot of different answers, and I can predict my classmates might have something completely different here. I'm going to keep this simple, and I'm just going to say that the x and the y-axis represent distance. And I'm going to say that's distance in feet. Now, I could do a lot of different things. I could do distance over time, but I'm going to do distance because this is my story starts here, where this is a football throw competition on a football field. So if I'm trying to win this contest, there's really 2 things that I could try and do, and that's throw the ball the highest or throw the ball the furthest downfield. So my story, which is actually going to allow every team to win, goes like this. The green team threw the ball at a initial angle much greater than the other 2 teams with the most power and was able to reach a maximum height of 83 feet in the air. That's all the way at the top. So the team green, we'll call them, threw their football the highest. They won the contest that was on height. Now, the red team did not throw the ball the highest. They actually threw it the furthest downfield. So they won the distance downfield contest because they threw their ball 50, or we'll say about 72 feet down the field. Now to get that, I didn't just find this number. I took the difference between my 0 at this, my first 0 and my second 0. So this was 82, this was 10, we said. That's a total distance of 72. And I compared that to all the other differences, and Team Red threw theirs the furthest downfield. Now, in today's world, every team has to win. So I got to think about what contest could I allow, or could I say that the blue team won? And I think the best would be, not only do you want to, in football, throw the ball really high or really far, you want to be accurate. So I'm going to say that they were the only team that were able to hit my little wide receiver who had a fixed position of 72 feet down the field. So if this was 72, and I said if the quarterback and wide receiver were standing next to each other, and I told the wide receiver to go 72 yards away down the field, the quarterback would have thrown the football right to him so that they would have a completed catch. So green, great job, you won the height contest. Red, great job, you threw it the furthest down the field. And blue, great job because you threw it to our open wide receiver.